In a complex engineering system, it's critical to understand how all of the parts are functioning at any given moment. When that system is in a harsh environment, it becomes even more critical. Imagine if you had a way to constantly monitor the system, regardless of where it is. For a number of its systems, NASA has relied on a small company in Conroe, Texas, to provide monitoring solutions. Invocon has been developing miniature, low-power, wireless data acquisition and communication systems since the mid-1980s. Early on, the company's president, Carl Kiefer, envisioned putting a network of sensors on a NASA structure, each sensor acting as a relay source for the network.
We produced drawings of astronauts floating around, a drawing of what we thought a space station might look like. Those astronauts are floating around putting little sensors on the space station. I think it was 12 years or 10 years to the day later, we actually watched astronauts live put our system and install it on one of the tops of the trusses of the space station.
Today, an Invocon internal wireless instrumentation system, or IWIS, collects data on the impulse response of the International Space Station and verifies the station's integrity while it's in orbit. The firm is now building EWIS that will go on the ends of the station's solar array trusses to monitor the impulses that occur whenever the station is reboosted or has a docking. Kiefer compares the impulses to a tuning fork.
If you hit a tuning fork, it rings for a while and then it stops. So you can think of us as the ear that listens to the tuning fork response of the space station.
The EWIS will record the microgravity changes to the nearest half a millionth of a G when the station experiences such an impulse. Because of its success with monitoring technologies, Invocon was tasked to design a number of systems for NASA's return-to-flight shuttle mission STS-114. In fact, the firm actually had 4 different monitoring systems on board, and all 4 had their genesis in the SBIR program. One system monitored the leading edges of the shuttle wings for impacts. One monitored the stresses on part of the main engines during launch. Another monitored payload vibration during launch and landing. And another monitored temperatures during a thermal protection system repair experiment. Invocon developed various aspects of the leading-edge monitoring system to be controlled from the ground. A software glitch in the system did occur, and the firm's technology allowed engineers back on Earth to correct it. Although Kiefer was happy with all of their monitoring systems, he was especially happy about fixing that glitch.
I was prouder of that than I would have been had the thing just worked perfectly, because it was like Apollo 13. Not only did you do it, you saved the day.
Invocon is working with NASA on other monitoring solutions. They're collaborating with Johnson Space Center and the Navy to transition some technology to NASA that was originally developed for the Navy. The technology can map the spread of a catastrophic event, such as an explosion. Under an SBIR contract from Langley Research Center, the firm is developing technology that can identify the area of an impact on any space vehicle. As NASA continues on a journey of exploration, Invocon will work on providing solutions to monitor the agency's new systems and structures.